You're standing next to a huge floor-to-ceiling window of the spaceship/wandering city you've been calling your home for a dozen years, along with a few hundred other people. You're watching a fascinating object nearing your spaceship, wondering if it'll bring an end to this journey and your life. It looks like an asteroid, but acts like a comet, moving as if something is pushing it. Can it be the engine created by another space civilization? Are you doomed, or are you about to have contact with a different kind of intelligence? Now, let's leave this post-apocalyptic fantasy and take a closer look at these space invaders called dark comets. The most intriguing question is obviously, what makes them move? Most likely it's some gas or material escaping from the surface of these space objects. Interestingly, until recently, no one has even been sure they existed. The first dark comet was discovered just a few years ago, and since then, researchers have identified 14 of them, including 7 new ones found just recently. The story of dark comets began in 2016, when scientists noticed something strange about an asteroid called 2003 RM. Its orbit wasn't quite what they expected. It had shifted slightly, and no one could explain that shift by typical asteroid behavior, when they received tiny pushes caused by sunlight heating an asteroid unevenly. Instead, the movement suggested that 2003 RM might have been releasing material, something comets often do. But there was a catch. The thing didn't look like a comet. There was no tail, no visible gas cloud. It was just a tiny dot of light, like a regular asteroid. At first, scientists thought 2003 RM was just a one-off mystery. But in 2017, a telescope spotted another strange object, this one from outside our solar system. It was Oumuamua. It too looked like an asteroid, but had a path that changed as if gas were escaping from it. The similarities between Oumuamua and 2003 RM made researchers think there might be more of such odd objects out there. By 2023, 7 more had been discovered in our solar system. These discoveries were enough to give this new type of object the name of dark comets. Now, scientists have enough data to start noticing patterns and learning more about their characteristics. And so, they have identified 2 main groups of dark comets. The first group, called outer dark comets, is larger, with sizes ranging from hundreds of feet to even more. They follow long elliptical orbits, similar to traditional comets that come from regions near Jupiter. The second group, inner dark comets, is smaller, usually tens of feet across. These comets move in almost circular orbits and stay closer to the Sun, near planets like Earth, Venus, and Mars. The main question these days is, where do dark comets come from? Can they be the remnants of larger bodies that broke apart? These space bodies could help us understand the history of the solar system. What if they had delivered the ingredients for life to early Earth? Once we study dark comets better, we might figure out if they contain materials like ice or organic compounds. And indeed, some researchers are sure that dark comets may contain or once have contained ice and played a big role in bringing water to Earth. According to a couple of studies, some asteroids in the asteroid belt, a region between Mars and Jupiter filled with rocky debris, might have ice beneath their surfaces. And this ice from the asteroid belt could have traveled into near-Earth space. In other words, it could be a pathway for water to reach our planet. So far, no one is saying that dark comets definitely brought water to Earth, but they might be another mechanism for moving ice from one part of the solar system to another. The study also hints at a connection between dark comets and a group known as Jupiter family comets. These are comets whose orbits are strongly influenced by the gravity of Jupiter, often pulling them inward toward the Sun. This connection makes it even more difficult to understand where dark comets come from and how they behave. Now, let's take a closer look at the differences between asteroids and comets. Traditional asteroids are rocky bodies that orbit relatively close to the Sun, typically within the ice line. This region is so close to the Sun that any ice on an asteroid's surface would turn directly from a solid into a gas, leaving behind only rock. Comets, in turn, are icy bodies that form farther from the Sun. When they approach the inner solar system, their ice starts turning from a solid to a gas tube, creating a visible cloud called a coma or a tail while releasing dust and gas. Dark comets blur these definitions. They appear as rocky asteroid objects without a coma or tail, but they have behavior typical of comets, and that's small non-gravitational accelerations. These accelerations occur when ice turns into gas, giving the object a slight push. After analyzing 7 known dark comets, astronomers estimated that between 0.5% and 60% of all near-Earth objects might belong to this mysterious category. And since dark comets likely come from the asteroid belt, ice is likely to exist even in the regions of the belt previously thought to be too warm. Now, near-Earth objects like dark comets don't stay in the same orbit forever. The near-Earth environment is unstable, and objects typically remain there for about 10 million years. Since the solar system is over 4.5 billion years old, this means that new near-Earth objects must constantly replace those that are lost. Now, astronomers have used computer models to simulate the movement of objects under the influence of non-gravitational accelerations. They've traced the paths of these objects over a span of 100,000 years and discovered that many ended up in the same regions where we find dark comets today. Now, do you remember that space rock 2003 RM, which was the first to be called a dark comet? Well, it provided a particularly interesting clue. Its elliptical orbit brings it close to Earth, then out near Jupiter, before returning to Earth again. This trajectory matches what scientists would expect from a Jupiter family comet, an object that was likely knocked inward from its original orbit. Most of the other dark comets studied, however, seem to have come from the inner regions of the asteroid belt, closer to Mars. Dark comets are often small and spin rapidly. Astronomers often describe them as dirty ice cubes, all because these objects are a mix of rock and ice, and when they cross the ice line, their ice begins to turn into gas. This process not only causes those small non-gravitational accelerations, but also increases their spin rate. And the faster these objects spin, the easier they can break apart into smaller fragments. The pieces that break off also have ice, and as they spin faster and faster, they break into even smaller pieces. This process continues until you're left with very small, fast-spinning objects. This cycle of fragmentation helps explain why dark comets are often so tiny. But it could also mean there are more of them than we currently know about. The dark comet research provides new insights into the distribution of ice in the solar system and its potential pathways into the near-Earth environment. It also raises intriguing questions. For example, how much ice remains hidden in the asteroid belt? Or could dark comets have played a role in delivering water or organic materials to Earth? One of the most important points is that dark comets may represent a significant part of near-Earth objects. If it turns out to be true, it could mean that our understanding of the population of near-Earth objects and their potential risks for our planet is far from complete. The processes shaping dark comets, from sublimation to fragmentation, could be a major factor in the evolution of icy bodies throughout the solar system. Luckily, these days, scientists have an opportunity to combine advanced modeling with observations, which can eventually shed light on that very elusive class of objects that could have clues to the history of water and life on Earth.